Good afternoon, everyone. Before I get started, can someone please type in the chat box if you can hear me okay? Okay, great, thank you. On behalf of the ArcGIS Education Committee, I want to thank you for joining us for this webinar. We are looking forward to your comments and questions during the program. When you have a comment or question for our speaker, please enter it into the chat box at any time during the webinar, and the speaker will answer your questions. Without further ado, I would like to introduce today's speaker. Bert McAlpine is a GIS coordinator for Julie Inc. with over 19 years of GIS experience. He is a GISP and an Esri certified ArcGIS Desktop professional. He works with different entities around the state using GIS data to help in Julie's processes. Mr. McAlpine uses Python every day in managing base data for all 102 counties, Julie's 2,000 plus member data, as well as various SQL reporting and analysis. Today, Mr. McAlpine will be presenting a webinar entitled ArcPy GIS Finally, which is the third of a series of 4 webinars centered around Python. Please give your warmest virtual welcome to Bert McAlpine.
Thanks. So most of you, I'm assuming, have been through the other seminar or webinars. So you know who I am. Here's my contact information. For those of you who haven't, just real quick, why Python? Esri is really pushing folks to use Python. And it's pretty good for lots of stuff. It's got lots of free modules that come with it. It's got a whole bunch of free modules you can get to do other stuff with it. But it's not just Esri. You can do all different kinds of things with Python. Today, we're mainly going to start on the ArcPy site package, which is Esri's Python package. And under that, there's got a few different modules. So you got data access module. You got a mapping module, which deals with desktop, only desktop, not pro. And then you've got another mapping module, which is .mp, which is pro only. Other than those two modules, pro versus ArcPy in desktop is the same, other than the mapping versus the MP modules. You got spatial analysts and you got network analysts. Again, I've stressed this before, don't use a text editor. There's a list of some free ones. For the folks who have asked, I'm going to be using Microsoft Visual Studio Community Edition, the first one there. Those are in no particular order, just a list of some free ones. Python's a good tool in GIS to automate any repetitive task. So let's say you got a map book and you need to export it out every day or every week as the data behind it's getting edited. You can automate and script that and have it just run for you. You use Python and field calculator in lots of different places. You can use it in label expressions. You can do, if you're familiar with models, you can use it in it'll do everything a model do plus a whole lot more. Scripts, you can add them to a toolbox if you want to or not. You can run them in process, which means you can run them inside of ArcMap and it can interact with the current map or not. And you can also add scripts that do very specific things and just add them to a model if you're more comfortable with Model Builder. You can also schedule tasks to run the Windows Task Manager. ArcPy, there used to be ArcGIS scripting in ArcGIS 9, but we're not going to even, that's all we're going to talk about on that. So ArcGIS 10, that's when they came out with ArcPy. It's their main module. There's a Python window now, and pretty much all of their applications you can actually do Python right in the window. You don't have to have ID or anything else if you want to do that. There's some things that we're going to discuss today. Python environments. So ArcPy environments, you can set those at the beginning of a script or in a script tool. Like I use this one all the time, override output to true. So that way if I'm working on something repetitive, I don't have to keep going to disk and deleting it if I want to do some different versions. There's a way to get parameters from a tool. If you make a script tool, there's a certain way you've got to pass those in. The MXD, so this is specific to desktop. So if you want to access the current map, i.e. the one that's open, there's an option to call current, so you don't have to save it to disk and find it or anything else. They've got tools so you can add messages to your script tool as it's processing. There's add message, which is basically informational, and there's add warning. So you just get some sort of warning and it still runs. I'm sure if you run tools, you've seen warnings. You can also add an error, and that stops, that crashes the script basically. Also, if you're new to ArcPy, you can do ArcPy.usage and then put in the tool, and it will give you some information print out. Basically, when I say print, I mean Python print, not as in paper print. So you can see what the tool's about. And we're going to go over most of this today. One note is that there are new cursors available at 10.1, ArcPy.da. So this ArcPy came out at 10. At 10.1, they released a new version of cursors called ArcPy.data_access. That's the data access module. The other cursors are in there. So there's just ArcPy.search cursor, .update cursor, .insert cursor. Do not use those. Those are only in there so they don't break anything that you've written before the data access module came out. The reason not to use those is because the new ones are approximately 30 times faster. And they're still not super fast, but I mean, they're fast enough it shouldn't cause an issue anymore. The old cursors are going to pull your hair out. One of the big things is ArcPy is case sensitive, just like the rest of Python, but the tool parameters are not. And when I say parameters, that's, you know, in this case, that's the input shapefile and then how much I want to buffer it by. You can notice the top one here, it's all uppercase. Bottom one here, it's all lowercase. It makes absolutely no difference to the tool. But if I take my tool at the bottom and say arcpy.buffer lowercase underscore analysis, it doesn't know what that is because it's not the proper case. If you're using a IDE, it's probably going to tell you that long before you ever run it. You can use Python and field calculator lots of places. There's a few differences. If you're used to using VB script, your field names will be in a bracket. Python's going to be have exclamation points at the end of it. And then once you call Python the field name, you can do a whole bunch of simple stuff like one line, like replace, title, strip to remove white space. You can split and get the first thing. You got a whole bunch of different access. If you want to do something more complicated, you can still do that in field calculator. You can do a code block, and I got a slide on that coming up. If it's something that's real complicated, behind the scenes, field calculator just calls an update cursor. So it might be easier to call an update cursor to do all your calculations there. Or if you have, you know, a multitude of fields you're going to calculate, update cursor is probably the way to go. There are some built-in helper functions for geometries. So if you see shape at area at acres, when the little exclamation points, so that's going to return the geometry. Obviously, this is a polygon for this to work. Then dot area, and then at acres. So if I specify area unit, I can specify any of these keywords to get that back in whatever units I want it to. So you don't have to convert or reproject or calculate. Like if you need square inches, you can get it. If you need square millimeters, you can get it. I don't know why you would need square millimeters, but it's there. Same thing if you do shape dot length at. You could do centimeters, decimal degrees, miles, meters, yards, all those different nautical miles. All those different calculations right in the field calculator. You don't have to do anything else. Then you've also got some, you can also do Python expressions, again, inside the field calculator that look at type or the extent or the center or the first point or the last point, is a multi-part, count the parts, all that stuff you can do with Python right in the field calculator. So here's a quick example. The main thing in Field Calculator is you have to make sure, because it defaults to VB, make sure to check Python. And then when you click on field names, they'll show up down here with the exclamation points. This over here, list of functions. There's a few different types of functions. So if you're doing date stuff, you're going to have a list of functions, strings, text. You're going to have a list of function numbers. You're going to have a list of functions that are built in. This is just the function to make it uppercase. And if you want to call a code block, now this is a very simple code block, but you're going to check the show code block, make a function, which we talked about, and this could be anything here. So this is just my variable name, and then I'm going to call the function in. So right here is where my upper's at. Over here, I'm just going to say code, and then pass in the field name, and that's going to say code, and that field name is now my variable. And it processes, and I'm going to return something. There's lots of different instances I'll use that for different things. Cursors. We talked a little bit about with statements. So cursors make locks, or can, so they can lock your data. So if you're not using them inside a with statement, which you should be, you need to make sure to delete the cursor object when you're done with it. There's 3 types of cursors. There's a read-only cursor, which is the search cursor. That is your fastest cursor by far. There's a few things that are required. There's an input table, and then there's field names. It's best to specify just the field names you need, nothing extra. If you can, do a where clause. If you need to, you can change the spatial reference. So you don't have to reproject the data, but if you need the coordinates and the centroid for a different projection system altogether, you could actually force your cursor to that spatial reference, and you have access to that. The next type of cursor, which is edit cursor, and make sure not to use, or this update cursor, which so you're going to edit or delete, is make sure not to use this if search cursor would work, because update cursor is markedly slower because you're accessing it with the edit lock. And again, it takes 2 things that is required: input and field names, and it's got the same where clause, special reference, explode the points. So that will take a line or a polygon and give you the actual vertices. So each row would be a vertice of the shape. I haven't found a good use for that, but it's there. SQL clause, you can sort and order by a few different things. If you have SQL Server, you can do like top, so you can get the top 10. Then there's edit. So edit is the cursor you're going to use if you're going to insert data in to a existing table or feature class. Think of that as basically a way to append. It requires an in table and field name, and that's it. I mean, because that's just a cursor waiting for you to feed stuff into an existing table or feature class. SQL clauses, we talked about this a little bit. These are very important. I'm showing it here just in the select by attribute, which is a good way to test your SQL clause to make sure it's going to work. These 3 different clauses are exactly the same. So this is triple quotes, and then the field name and double quotes, and then a string. So this is very similar. I'm using my format, which we talked about, and there's my curly brackets that calls whatever this is. Now, whatever this is over here is pretty important. So ArcPy has a specific add field delimiter tool or function. So the way it works is, if you're familiar with SQL clauses, and they need to have different things for different data types. So a shapefile needs double quotes. Sometimes your file geodatabase will need single quotes. Sometimes your SDE or Oracle or Postgres will need a different sort of delimiter, quotes or single quotes or brackets or whatever for the field for it to work. So they have a tool that adds the field delimiters for you. So that way, if you have a tool that works in shapes and you got SQL clauses, it'll still work on enterprise geodatabases, file geodatabases. So it's a real simple tool. It's arcpy.add field delimiters. feature class, and then the field you want to call. In this case, it's going to be exactly the same as the rest of these. So there's another way you can do that too, is you could add that field delimiter to your other string. I prefer the format method just because it's more flexible. Sorry, the format method just was more flexible. And then add field delimiters just makes your code a little bit more flexible. A lot of times I'll be using shape files or feature data or file geodatabases, and if I do that, I don't have to worry about my SQL clause formatting. It pretty much just takes care of the field name formatting for me. There are some special tokens you can use with all of the cursors. So search, update, and insert. These tokens are kind of behind the scenes, and they make it so if you want to access this information, it's real easy to do. So if you need just the XY, the centroid, you can call XY rather than the full geometry. If you call the full geometry, that takes quite a bit of processing behind the scenes to get a full geometry object. The XY is just going to be a tuple of values. True centroid is similar to XY but different. If you don't know what the true centroid is, you can look that up. If you just need the X or the Y or the Z or the M, there's tools for that. If you're dealing with web pages or you're dealing with REST, you need it in a JSON. You can pull the shape as a JSON inside the cursor just by doing shape at JSON. There's a couple other things that are interchange kind of formats. So there's well-known binary. That's just a well-known binary. I mean, you can't read it really. It's binary stream, but it's the representation of that geometry as well-known binary. There's well-known text, which lots of stuff can read as well. There's a way to get it out. If you do need the full geometry, you can do shape at and nothing behind it. I use that some. I got some of that in my examples. Don't use it unless you need to. If you can get by pulling the XY rather than the full geometry, do that. Shape at area, you cannot specify the unit like you can in a field calculator. It's going to give you a double of the features area in the units of the projection system that it's in. Same for length. OID will give you the object ID field. So whether that's SDE, you know, like a GUID or a OID or FID, no matter what the field name is, it's going to know which one's the object ID and return that value. There's some online resources. This exact same slide and all the other ones. There's a few little extra tidbits here just for you can look at real quick. We're not going to discuss them other than this. So you can't multi-thread, if anybody knows what that is, but you can multi-process. We're not going to go over that, but that's something to keep in mind if you have a whole lot of data. I'm talking lots and lots of data, like hundreds of thousands of records or millions of records, and it's taking a long time to process. And you got a multi-core machine. ArcPy and Python's only going to use one core. So if you need to split that out, look at multi-processing. There is a little bit of information that on the Esri help site too. Also for speed, make sure to limit the extent. So if you're doing raster processing or something like that, you can set the environment of the extent. Make sure to limit the extent to what you need. That'll speed up things. Where clause on layers and cursors makes a huge difference because you're not dealing with data you don't need. But if you use something in process, which is inside the ArcMap or inside Pro, it saves a little bit of time because it takes 5 to 10 seconds to import ArcPy. So that 5 to 10 seconds when you run out of script, it has to import. So it's going to add that to your processing time. And you can use layer selections over intermediate data if possible, if it makes sense. Do not write intermediate data to your SDE. Just don't do it. It's really slow and it's not a good way to do it. And it's intermediate data, so it should go away at the end of the process anyways. You can use in-memory for intermediate data if possible. So that in-memory writes those, think of it as a low-class file geodatabase. It doesn't support feature data sets, it doesn't support topography, but it supports feature classes and tables. And it's a real good tool for intermediate data, because as soon as the script runs, everything in memory just gets dumped. You don't have to delete it, you don't have to clean it up. It's not going to linger in your default geodatabase. That's something I use almost all the time. And since you're not writing a disk, sometimes it can make your scripts much faster. And don't use unknown coordinate systems. It's best if you can have everything in the same coordinate system, but not absolutely necessary. So for Python inside ArcMap, it's 32-bit. So you only have 2 gigs of RAM for Python. So if you're using in-memory on real big data sets, you might run out. If you run an outer process and you have background geoprocessing installed, you run 64-bit. So at that point, you've got as much RAM as you have installed. So, and that's what I do most times, background. Or ArcPro, it's 64-bit. There is no 32-bit to worry about on it. You can adjust the Python exe if you want to. There's a little bit at the bottom slide. I'm not going to get into that. I do it sometimes, but at your own risk. And there's a little blurb about in-memory just on itself, because I use it all the time. And then that is the last of the slide stack. So we're going to get into looking at some code examples. So I asked for examples and I got a few. So we're just going to jump into some of them. So we're going to be going back and forth between the desktop, and this would be the same if I was in Pro. This stuff that we're going to discuss right now makes no difference. So if you're not familiar with your Python console, there's a button right there, and that opens your Python window, and I'm going to just pin mine down there for now. And actually, I'm going to hide it. So somebody asked, how do you do a spatial join? So I'm going to assume you know what spatial joins are. So I want to take one feature and join attributes to another feature based off location, rather than based off of a join key, like just a regular join, a tabular join. So I'm going to search for join. We're going to do this manually first, so you can kind of see what's going on. So I'm going to do a spatial join, and I want to know, so these are water main breaks, and I got water mains. So I got water, or I got my main breaks, which are points. That's going to be my target feature. And I want them to have the information of the nearest water main. I'm going to write this just to my default geodatabase. You can't use in-memory when you're in here. It'll automatically default to your geodatabase, and you can't, even if you change it, it'll still write back to your geodatabase. If we look real quick at some of this data, you can see that it doesn't touch. So there's a few options of the tool here. We're going to leave this default. This is one-to-one. You can do one-to-many. There's help on all these tools. If you need help on any tool, when it's open, you can click the tool help. First thing you see is the license level, to make sure you have the right licensing. And then there's some syntax. So this is the syntax you use in ArcPy. Everything in a curly bracket is optional. So you only have to specify 3 things: target feature, join feature, output feature class. Everything else is optional. In our case, that's great, except for when we look at match, because the default, it's kind of hidden in there, it says this is the default, is intersect. And that doesn't work, so we need to specify something else for that to work. So in our case, we could either add a search radius. So I could say intersects within 30 feet. But I think for this case, I want to do the closest. And I'm just going to do, there's closest and closest geodetic or geodesic. The geodesic obviously takes in the curvature of the Earth, which is technically a little bit more accurate. In our case, we're just going to do the regular closest, which is planar. Not going to add a specific search radius, and I'm going to run this. It doesn't take very long. It's done. So I'm going to open up my results tab. If you're not familiar with the results tab, you can go under geoprocessing and then results, and that will open this window up. So any tool that you run shows up here. Failed, lose, draw, it shows up in there, and it'll show a triangle or red if it fails. But let's take a look at our data real quick. There's a whole bunch of fields in here. I didn't even look at what they were, but the output is a join count, and we want to make sure something got joined to it. And then there's a target FID, and trust me, but all of the water main data got copied over based off the closest water main to that point. But the nice thing about running it manually, and if you're stepping through something, it's not a bad idea to run it manually. You can right click on anything that runs and completes with a warning or without. And you could share it as a geoprocessing package. You could share it as a geoprocessing service. For us, since we're doing Python, we're going to do copy as a Python snippet. Now I'm going to warn you, there's a lot of stuff in here. So I'm going to paste this down here where we can see it. All right, you're like, good Lord, that's like 50 lines of stuff. So default, whenever Esri runs something, they spit out everything. So even all the parameters that are blank are still spit out. Everything that's default is still spit out. When you're down here in this window, though, it's got really good IntelliSense. So if I type ArcPy dot, I get everything that's available for that, and there's a bunch. And then when I get inside a tool, I can click on the target if I want it to be a target. But also in the help panel, I get some information about where I'm at. It highlights where my cursor's at and what it's looking for. And then there's a bunch of detailed information, inputs, join features, join operators. It just keeps going. There's really good help in here as you're going. And there's descriptions of, the different types of match features. And all the tools are going to be similar. They're going to have all this documentation basically built into them. So this, if I were to execute it, does the same thing that we just did manually. And I'm going to run that. And it ran. Table was not found. So apparently I lied. But I'll get rid of all this stuff. I'll show you what you actually have to have. So I need my target. So put a comma in. I need my join. And then output feature class. So at this point we can put it anywhere. I'm going to put it in here. And if you want to, you can. So what I did there was, so you can either call these by name. So this is the match type. So I could say match equals closest. In this case, I just put in commas and I started skipping through all these other parameters. So now that should run. It doesn't like it. We'll do. So the pound is also the default. All right, so apparently it doesn't like something in there. I don't see it, but I promise you it runs, or it should. see if it just runs on its own. Live demos. Okay, so intersect ran. But the issue with intersect, if we'll see in here, is our join count. So only three of those had joins because we didn't specify a search radius. So just be careful, be familiar with the tool whenever it runs. There is one other thing that we should discuss. So I'm going to copy that as a Python snippet again. I'm going to right click and clear all that. I hate seeing red. So there's this thing called field mapping. I suggest you don't do field mapping inside of Python. It is very painful. And the field mapping is let's see, all that highlighted code is just the field mapping. Field mappings, in my opinion, is handled very poorly. In this case, we didn't do any field mapping, so it can just be omitted, and that works fine. So that's the basics of how you do that inside of the Python window. And if we do, let's see, ArcPy dot usage. We do ArcPy dot spatial point. So the usage is the one where you put a tool and it gives you information about it. So it didn't print really well. And you can do this inside your IDE as well. So I'm going to print that. Just running it didn't take care of my new lines. So now everything's formatted and you can see it. So if you're dealing with IDE, you don't have access to all this information. Your IDE should provide it to you as you're working on it. You can do print and then get the usage of any tool that you're trying to find out, and it's going to give you all this very robust information about the tool. Let's look at that same example and just the standalone code. So we got to import ArcPy because that's what we're going to use. I'm going to set my environment here, so I could set out. I'm going to set output to true, so I can overwrite the output. If I wanted to specify any of the other, actually, I guess I showed that to you. So if you're not familiar, all the tools, almost all of them anyways, have the environments tab. So any of this stuff you need to set, workspace, resolution, output coordinates, all of that information can be set in the script tool. And here I'm just setting output true. Put a link in for the help. This is the online help, which is normally much better than the on disk help. And when you go to the online help, if you're using a different version, you might just check on the version you're using. But if you get to down here towards the bottom, it'll give you syntax again. But it's also, again, on all the tools, you're going to get a code sample. This looks very familiar. Target, input, output. So that's Python window. This is standalone script example. And then, so I mean, those are good starting points to be able to deal with that. The same way for any tool. So in here, I'm just going to set a target, a join, output. Output obviously doesn't exist. Input and target do. If my output doesn't exist or does exist, I'm going to overwrite it because I set that to true. And here's the nice thing about a debugger. So I'll set a breakpoint. I'm going to start this code with debugging. So that window is going to remain open. But I'm going to step through the code. So what's taking so long right now? Uh-oh. This is not signed into Portal. Oh, all right, hold on. So I didn't sign into my ArcGIS Pro apparently. Let me get my super secret password. User. And the reason I got that error is because I'm using Python 3, which is the Pro Python. I got to look my passwords up. Password. All right. Well, that's aggravating. Let's see. Let's try another account. I've got like 15 different accounts. Got the username. Password. Not it. Username. Nope. It's not it either. All right. I tell you what. We're just going to switch our environment, since that's being a pain, over to. So in most of your IDs, you're going to be able to switch your environments. In this case, I switched to my desktop 64-bit 10.7 install. And now I'm going to start with debugging. And you can tell now that this is the one it fired up. And so now it's working. So I'm going to step through this. So now I assigned a variable. I got target. Gives me my variable. Step through that one, step through that one. This one here, I specified a match option as closest. If I hold over the tool, I get some information. Like in my case, it says target join, output class, and a whole bunch of stuff is none, which most of those are going to be default. And then if I just keep stepping through this, it's done. So, and when I call it in the script, it's the same thing. So these two lines are the same. So this has anything with curly brackets, again, is optional. You don't call it unless you have to. You can call them by a keyword. So then in this case, I want to specify this optional variable. I just say a match underscore option equals whatever I want it to be. I just commented that out so you can see it. You'll have that too. So I'm done with that one. Done with that one. All right. Nope. So here's a buffer example. I mean, lots of, and not all these examples will work with any tool. As far as, whatever you want to do with it, you could do hotspot analysis if you had points. You could do all kinds of different things you could automate. This is just kind of showing the bones of how stuff works. So I got 1 point. If I look over here in my home folder, I've got 1 point in MXD. So I want to buffer this. I'm going to set my override output to true. I'm going to specify my input, and we're just going to start stepping through this. So, and we'll talk about it as we go. So with debugging, and when you run with debugging, it is slower. So in this case, I just defined a point shapefile. Now from that shapefile, I'm using OS, which is import operating system, and I'm going to get the directory name. So of the full shapefile, I'm just going to get back this portion here, and then I'm going to store that to use it a little bit later. And now there's my usage example again. I'm going to print it. When you're in debug, it prints that to the console. And so this is what it looks like when it prints. Again, we saw this stuff a little bit earlier. So now in ArcPy, I'm going to run that. And so that ran, or is running. Okay, that ran. So it's on disk as this path folder buffer 10. And if I open that up, Let me just pin that open and refresh it. But of course, I have, true enough, I have a buffer underscore 10 feet. So anything you do in ArcPy, almost all things you do in ArcPy, sorry, field calculator doesn't have a new output, but this is a results object. So if I do buffer, I'm in my lower window now. I'm just going to call that. It says it's a results, and there it is. So I can take that results and pass it into my next geoprocessing tool if I want to, which is what I'm going to do. So I'm going to run that piece of code. So now I took my buffer result and I added 10 feet to it, so now it's a 20-foot buffer. And if we double check, it is sure enough right there. And you're like, yeah, that's pretty simple, pretty quick to do. Well, let's say for some reason, I have no reason really, but for some reason, I need to make a buffer from 10 feet to 500 feet in increments of 10, and I'm not going to do that by hand. So I made a little loop that says I'm going to start at 10 and go to 501, because if I say 500, it's going to stop at 490 because it does not, the range does not include the last number. Then I'm going to go through and buffer. So my number is going to be X. So it's going to be 10, 20, 30, 40. And it's going to insert X into my output buffer name that I'm building here. I'm going to check to make sure it exists. If it exists, I'm going to print it already exists. If it doesn't exist, I'm going to go ahead and process that shape. So we'll just step through this. So I just made a buffer name. So there's my new name. It says buffer 10 feet. So if you're not sure if something's there on disk, there's an ArcPy exists, and it does exist. So ArcPy exists returns true or false. In this case, if we scroll down to the bottom and I hit print, it should say true. It did not say true. Oh, there we go. Already exists, sorry. So it says output already exists. And we know we already have a couple of these, so we'll step through them. And at this point, I just want to break when I make a new buffer. So I'm just going to hit continue. The nice thing about doing IDE, this is really good when you're testing and debugging stuff where you can interact with the code as it's processing. So now I'm going to say that doesn't exist. X is 30, so I'm at 30 feet. I'm going to let that run. So I'm going to make a whole bunch of buffers real fast. Debugging is slower than if you were running on its own. It's already done. If we refresh, now we have a whole bunch of buffers. Esri sorts them a little funky because it looks at just the first digit, but they're all there. Another thing you can do now that you got all this information is well, here I guess is kind of a separate but still the same example is, I know I have a whole bunch of polygons. I want to find all the polygons, in this case, in that directory. It doesn't have to be that directory. I could have searched the whole hard drive. I could search the whole server folder, and you can access stuff that way. This is the DA walk. This is what you want to use if you're looking for spatial data, because it'll look inside of file geodatabases, look for shape files, look for rasters. In this case, I set the data type down to just feature classes and just polygons. So if you want to do data inventory, that's another option for that. So in this case, I'm going to go through this directory and get all of the file names. And if that will go away, I'll step over this one again down to here. So that's how long it took to get all those file names. And if we go to interactive and do poly CF and If I do lens, so that's just a list, and we talked about list already. So now I got 50 polygons as expected, and Python snippet available in Pro. Yes, it is. Again, it's going to copy a little extra stuff out just to make sure it works, and it's going to have some comments in it that you need to address, like I'll say change the file names and everything else. So now we got 50 polygons in my list, and there's this. So in this case, now I've got a list of all these polygons, and now you have a list. You can do anything you want to with it. In this case, we're going to add some fields and calculate some values for all of those 50 ones. But let's say you need to reproject every polygon on your server to make sure it's in the right projection. So like if you're in Illinois State Plane West, and over the years you got some stuff in UTM, you got stuff in State Plane, you can loop through there, you can call a polygon, you can check the coordinate system. If it's not right, you can reproject it and then rename to eliminate the old one and have everything reprojected. This is just a real basic example of how to get your feature classes and deal with them. So I'm going to call a loop here. So I'm going to loop through all these. This is going to be a constant. So this new fields is a tuple of tuples. I could have done a list of lists. Same thing, basically. It's a little bit, since I'm not changing it, I just went ahead and did a tuple. So I'm going to get the first value. So the first value of that tuple of tuples is the first pair. So I got field 1 and text. If I wanted the first value in that, I do 0. So now I get field. I get 1. And we went over that a little bit. So I'm indexing my main tuple to get 1, and I'm indexing the individual tuple to get whichever one I want. So in this case, I got my polygons. We're going to hit the first one. I'm going to add a field. I'm going to call P, because that's how I'm referring to these. So now if we interrogate P, P is my buffer underscore 10 feet. And I'm going to add a square foot field, and it's going to be long. And then after that, I'm going to add another field, and it's going to be acres, and it's going to be double. You know, doubles, long, shorts, all that good stuff. You can calculate whatever you need to do. So now this is a long, I won't have any decimal places. I don't need a fraction of a square foot. Full square foot's close enough. That's why I chose long. There's some help here. I'll click the link just real quick. This is the help for the field calculator, and it has examples, a whole bunch of examples. Calculating null values, Python, you just type in none. That's a little aggravating until you figure that out. So if you have a table that you need to set the values to null, you just type in none, not quote none or single quote none or double quote none. It's just none, which is a Python none type, which is the equivalent in Esri to null. We're not even going to look at that. The link's in the code. Y'all are all going to get the code. Let's see. So now I'm going to calculate field. I'm going to say we still got P, square foot. Now I'm going to call it field calculator. So, I mean, this is something you could do straight in the field calculator inside a map. Say, give me the geodesic area at square feet. And I have to specify Python or Python 9.3 or VB script, depending on what I'm using in my expression fields. We're doing Python because this is a Python workshop or a webinar. I wish that would go away, Dr. Bottom. There we go. All right, so I'm going to step over that one. I'm going to calculate my area, my acres. So now I still got P, which is my 10-foot buffer. but I called this list of fields earlier. So new fields again, we'll look at that real quick. New fields. So again, it's a tuple of tuple. So I got one shapefile, and now I'm going to add 1, 2, 3, 4 different fields to it in a loop with only 2 lines of code. So as we step through this, so new fields 0, which is what we have, is field 1 and text. If we interrogate F and T, it's field 1 and text. There's something that's very useful called unpacking. So if my new fields, whatever that is iterable, in this case it is, I have a tuple, this tuple to be precise is the first one, and if I give it 2 variables which match the number, it automatically assigns those for me. The other way to do that is to just index them, which this code snippet, these are exactly the same. Exactly. They would function the same, exactly the same. It's just a little cleaner and neater for me to do that rather than doing a double index. Either way is fine. Do whatever you're comfortable with. If you see examples this way versus that way, there's no difference. There's no performance difference. It's just a little different. So in this case, I'm going to take my feature class. I'm going to add field 1, and it's going to be text. And I just told it to run. So now I added those 4 fields, and I'm going to add 6 fields to my other 49 shapefiles. And I got that stopped in time. I may have ran. Uh-oh. So I crashed. So that trapped the error, and it said the field already existed. I don't know why, because it shouldn't have. So let me rerun that real quick. Take off my other stops. Start with debugging. Now it's making those 50 buffers again, or it's going to print out they already exist. So there's the first field it created. Now F is the second field, and it's a date type field. And now F is the third field, and it's a short field. So it's that one. And then we're going to hit the 4th top as a float. And it said, oh, what have I done? All right, that worked when I tested it. Now it's not happy. Let's try that one more time, and then we're going to go on without it. Start with debugging. And there are bugs in Esri code, and every now and then you'll come across one. I don't know if this is a bug, but it did work fine yesterday. I did have some issues with my backup software causing locks. And it's home. All right, start with debugging. It's running. Should tell me a bunch of stuff exists. And if I get an error, I'm just going to comment that code out. Yep, I still get the error. I'm not sure why. It worked in Pro, which is where I tested it. Of course, I'm running it in Desktop, so there must be some slight difference. So I'm just going to comment that out right now and rerun this. Because the reason I'm rerunning it is because I'm going to delete all this junk at the end. That way y'all don't get it when it's done. So you're going to start without debugging, which runs faster. When it gets done, there'll be pressing the key to exit. I am not sure why that doesn't work, and so it's done. Not sure why that doesn't work in desktop. I would have to investigate, but that is unfortunately not super uncommon for the differences for that to work. Let's see here. So that's done. Yeah, if I go into my buffer now and I refresh, the only thing that'll be left in there is the point file, because the last step I went through and I said, because I know I have buffers from 10 to 500 increments of 10, and I just called delete just to get rid of them. So that's a real simple example. Let's see. Don't use a text editor. I use Microsoft Visual Studio Community. Somebody had asked about post and reconcile, and this one is right here. So there is this website. It'll be in the code. This is Esri's example. I didn't write any of this. It goes over what it's doing, says find connections, parse connected users. Now they're going fancy and generating and sending an email. This assumes you have a like at julie.com email address. And you can email everybody. It also goes into blocking connections if you want to do that. And it's waiting 15 minutes here. This is what the import time sleep is. I don't know if I can see that. So that just waits 15 minutes, and then it's going to kick them anyways, because as an admin, if you have to run this as an admin to be able to post and reconcile. You're going to boot to users, and this one here, this tool here, if you're not familiar with reconcile versions, make sure you check the options, because you got the options to do all kinds of different things. You can reconcile all versions, you can do a version list, you can acquire lock, you can do favorite target as far as reconciling, you can post or not post, you can delete or keep versions, and you can generate a text file. If you don't know what all that stuff means, you probably don't need to run this remotely yet. And then you need to compress your database, and then you need to reallow connections, and then it's best practice to rebuild indexes and update statistics, and all that information is in here for you. It's also on the script. I do caution you, and this is one that would be perfect to schedule. So you could set this up, change everything to be where you need it to be for your system, and go ahead and get everything ready to go. Fire up Task Manager, tell it I want to run Friday nights, or whatever you want to run it. So the rule of thumb is, if you're doing several edits a day, do it nightly. If you're doing several edits a week, do it weekly. I warn you now, if you have not run reconcile, post, compress in a while or ever, don't do this except for like on a Friday, because it may take hours and hours and hours to process. When everything's up to date and your versions are reconciled frequently, shouldn't take very long at all, unless you're doing thousands of edits a day, and then it still should finish overnight without issue. So that's their example, and they will actually support that too. So if you have issues with it, you can actually hit up, assuming you have maintenance, Esri support, and they will they'll hit you up with help on that 99% of the time. Help has gotten much better over the years. There's another example somebody sent in, and so it's 3 o'clock. We're pretty much officially done. I'm going to keep going for a little bit longer because there's so much stuff that I want to cover. And so I got a couple of different examples. I'll cover this one, and that'll probably be it. This example, I warn you now, is complicated as far as the logic. So if you want to bail off, you're not going to hurt my feelings. If you want to hang on, it's fine too. So there's I'm going to get rid of that one. Nope. So this example here, we have service lines, which I didn't know were two pieces until I'd already written a solution and had to completely rewrite it again. So make sure you look at the data and make sure you know what you're getting into before you start. If somebody else sent me this data, I just looked at it. I'm not going to provide the data, but I'll provide the script. So what's going on here is these service lines, there's a private and public service line. They need the information from the building footprints. There's I've muted all the other, I've turned off all the fields we didn't need. So there's a full address field, and there's a location ID that the service lines need to have. And in this case, they have them because I ran it. And I already made a script tool that will open. So there's a tool in here. I made a model that has no parameters. So I guess that is something to bring up too. Your tools and script tools don't have to have any parameters if they don't need them. You can have everything hard coded in. In this case, I calculated 2 fields to be null, or empty strings in this case. So now if we look back in here, my service lines are nothing. So this provides a little bit of complication because I was looking at just doing a nearest, but I couldn't do nearest the way it was set up because I looked at doing intersect first. Well, the service lines don't touch the building footprint all the time. If they did touch, you could use select by boundary. And there's some cases where when you're looking at the separate pieces, that service line is 41 feet from this house, and this service line is 50 feet. So this service line obviously goes to this building footprint, but if I did closest, it would say, oh, well, I'm going to assign this value. Obviously, if you could have these closer, you would have a better percentage of match. The way I got around that is I dissolved these into one line that touched. I just did the dissolve into a single part. So rather than 2 pieces, now it's 1 piece. And then I process the data. So let's run this tool real quick. Building footprints. So it takes building footprints, it takes a water service line, and it takes a search radius. In this case, I know 5 does a pretty decent job. And like I said, this is a pretty complicated example, but you'll have it. I cannot share the data with you. The person who provided it didn't say I could, so I'm not going to do it. So these are some warnings. So this first one is a message. The green ones are warnings. Apparently this person was using the attribute transfer tool. We had to click on the line and then click on the polygon to transfer the attributes. And then I also have some reporting at the end. So I said 100 features of 132 that need to be updated were updated. So we still got some that were not. That's because I used a 5-foot search radius, and you got to, at this point, you'd have to use at least 30 feet to hit that building. So I dissolve those, I get the nearest information to that, and then I say, okay, now that it's dissolved, give me the 2 lines that the dissolved line touches. So it's a little complicated. So I'm taking blue line and the red line, making them 1 line, pulling the nearest building, which in this case, 40 feet versus 27. I looked around quite a bit, and that seemed to work. Of course, any solution you do, you're going to have to double check it. And we got this is just a subset, obviously. The black is the main and also service lines. So if you want to see how that works, oh, and also if you want to copy it, copy as a Python snippet, you can call your tools you've made as well. So in this case, I'm going to do ArcPy building footprints, and that's how I'm going to call this tool. And so if I need to call this tool in a different model or something else, I could call it that way. But here's some of the comments I was talking about. It says replace a layer, table viewer, path to data set, which is a layer file, or create, follow the inputs. This is a pretty simple one to do. So the logic behind this is a little convoluted. First off, all of the stuff that I write, I have a template for. So every IDE is different. And this one I have the option to do a template. I made my own template. All my templates look exactly like this. I've got it built in where it does the name for me, does the year for me, then I modify them as necessary. But I got import ArcPy because most stuff I'm doing is import ArcPy. I've got a worker function stubbed out. I have a try, and I got accept for ArcPy errors, and then accept for Python errors, so I can see what they are. And then this little line of code, I can run this as a script tool, I can run it as a standalone, I can call it from another tool. You don't have to understand exactly how that works at this point, but that's why that's in there. This is actually a template from Esri that they had years ago that I still use. So building footprints. I add a little bit of information about it. So created, modified. I said which platform I'm working for. Sometimes you write something like my buffer code apparently that doesn't work in desktop. So I would set this here to Pro only. There's not a whole lot of stuff that does that. So in here I haven't changed anything, but I'm making a building function. So this is the code that script tool runs. So if we look at the script tool, so I just right clicked on it. Now I got parameters. So my 3 parameters, footprints, water service, search radius, are the same parameters for my tool. The names don't have to match, but the orders have to match. So the building footprint has to be the first parameter, the water lines has to be the second parameter, the search radius has to be the third parameter. So the way this works when I call it from a script tool is it calls this function, and I'm getting all of the parameters as text, and I stick them in here. It makes a tuple, and then this is unpacking my tuple. So I know I have 3 variables here. It's going to unpack them and call this function. So I added a little doc string on here, so I got some idea what's going on, especially if I import it from a different script. And we talked about that a little bit. Added a lot of comments in here. So first thing I'm going to do is I'm going to limit the data I'm dealing with. So I filled delimiter. I said buildings full string because I got shape files. I know the person who sent it to me, they sent me a screenshot. It was SDE. So if I put delimiters in for a shape file, they're not going to work in SDE. So I added fill delimiters. I make a SQL statement, and then now I make a feature layer. So I'm going to do some selection by locations. I can't do that unless it's a layer. So at this point, I'm not changing the data, I'm just getting a subset of it. So I'm saying, give me everything that's not a no address, because all the no addresses to me look like they were detached garages. So we're just going to exclude them. The less data, the better. And then in this case, so I also put in delimiters for my, I'm making a layer of the water lines. But here, I only want water lines that are empty, a single space, or null. Because if I already have a value in them, there's no reason to reprocess all those. And that's a huge time saver because I just processed 100 of them. I've only got 32 left. So if I want to process them at a different buffer level or a different search radius, sorry, to try to fill some more of those in, I'm only processing the ones that didn't have a match that was real close. So here's the water surface layer I made using my SQL server, my SQL clause. This is just text, but I assign it to a result. So now whenever I need this layer, I'm just going to call this WS layer. Same for the building layer. When I need to access the layer, I'm just going to do BG_layer. I don't have to point to it on disk or anything else. Update cursor class, there's a link to help on that. Because we're going to be using that. And also the tokens. So I need some fields. I need address and location ID from the water layer. I need the building full address and location ID. I'm going to assign it empty. So that's just a tuple. So anything that's in this value, I'm going to test for it to see if it's quote unquote empty or not. I'm going to get a count. So previously I used my selection up here, my SQL clause, to get me a layer that this stuff needs to be updated. So it's blank, one space, or null. There's a chance that you can get 0, which isn't an error. Your layer is just empty. So I want to get update count, and then I call get count, and then I say if it's 0, there's no features that need to be updated. Else, I'm going to take how many records need to be updated at this point. And I'm going to add a warning because you really shouldn't be running the tool if it's empty. So I just want to make sure you're aware. And down here, I'm just giving you informational message. And so the first step I'm going to do is I'm going to dissolve the lines. So if you remember, we got the 2 lines, the private and the public. Let's go. So, and if I did each one of these individually, it would cause issues. So I'm just dissolving that down into one piece. Dissolve actually doesn't have to have any fields. So I'm just calling the layer. I'm saying dissolve, and in this case I'm using in memory, which is what we talked about. So it's writing it to my RAM, not my disk anywhere. I want to make it multi-part, and I want to unsplit lines. Most of the time you would call fields if you wanted to dissolve by fields, but in this case I'm just dissolving by geometry. And so now I made a counter. I said updated count, which is 0. We haven't updated any records yet. Every time we update a record at the bottom, we'll add 1 to that. So we can do some reporting at the end as far as how many got updated. So this is going to get a little hairy because there's a cursor inside a cursor inside a cursor. So first off, I'm calling search cursor. So I'm just looking at the data. I'm not doing anything else, but I just want to look at it. So I'm going to call my water lines dissolve, which I just made here. So now those 2 pieces are 1 piece. And then I'm going to get the shape. All I'm gets the shape. I don't care anything about the attribute data. So if you remember the tokens we talked about, this is shape at, this is the full geometry. So in this case, it is the line and all the points that make up the line. So now we started a cursor, and in this cursor, I'm just going to say my row is a shape. Just because row doesn't make a whole lot of sense to me. But when I give it a variable of shape, I'm like, oh, well, that's my geometry shape. So in this case, I'm taking that geometry object and I'm going to stick it into a geoprocessing tool, which you can do. You can take a geoprocessing or geometry object and stick it into almost any tool. I'm going to convert this into a full-fledged feature class. So at this point, I'm going to make it in memory water service underscore temp. Again, in memory, so there's no worry about garbage collection or cleanup, or if it fails, there's a whole bunch of stuff on disk. So there's my result, which is a feature class, and now I'm just going to make it a layer. And now I need to see which building is near this one line. And remember, we're in a cursor. So this cursor is a list of every row. So row is the first row. So this is just one shape object. This isn't the whole feature class. This is just the shape object of the first row. So, and now I'm going to say that I have a feature class that I converted to a layer. I'm going to call select by location management, which is, if you go in here, well, actually it'd be this tool. Oh, sorry, wrong button. Select by location. Same tool that we're running. Just running it inside the tool a little different way. So this is going to give me the building that is closest to the water dissolve layer single geometry that I just created, the single row geometry that I just created. And I said search radius, so as I'm looking at stuff, I'm looking for intersections within 5 feet. And I want a new selection to make sure I'm not getting a subset or working with the previous selection. So now I say, okay, I got my buildings. I should see how many I got. If you should get one, because it should be one building to one service line. So I got to check. So here's my building counts. If it's equal 1, I do some work. But here is a different thing. So I collapse that code because I want to say if it's not equal to 1. So if it's equal to 0, there's no building footprints near the water service. And I do a little formatting to show you the shape centroid X and the true centroid Y. So you can find out in your warning message where the issue's at. Like, okay, that one there, there's no shape for it. Similarly, I need to handle if there's more than one building footprint, because at that point I have no idea which one's going to be the right one. So that's going to take some manual investigation. So that's why that's in there. Our logic stream continues is if we have one building count and we got one geometry we're dealing with. So now I'm going to open up another cursor. So we'll keep track of what's going on here. I open up one cursor on the dissolved water lines. I selected my building. If I have one building, I'm going to open up another cursor. Again, a search cursor, because I don't need to edit anything. I just want to look at it. So my building selection, which we just did right here. So it's just a selection layer. So it's just that one feature. So when a cursor opens, it's going to be one feature. My building fields we assigned outside of the loop, because it's always best to assign stuff that's not going to change outside the loop. So that's our fields there. And now I'm making a new cursor. So I've got one. I have this selection going into it, which is one row. I've got these fields. I actually have fields locate ID and address full. This is going to return a tuple of those two fields. So I'm just unpacking that value into the tuple. So there's S row is basically this. S row is, so first value, second value. Same way I did in the for loop, I'm going to unpack those, stick them there and there. So that way, rather than dealing with S row, give me the first one, give me the second one, I can say, oh, okay, I know what I have is full address and location ID. It's not such a big deal when you're dealing with just a couple fields, but you get dealing with 15, 20, 30 fields. That is the way to handle those, so you have some idea of what's going on. You can keep track. So I got full address and I got location ID. Those are just values. They're not spatial. I didn't even call anything spatial. I just called those two fields. I don't want to call geometry unless I need geometry. All right, so now I've got my water selection layer, which is the original data, which is the two pieces. So now I have that. I'm going to intersect that, again, using select by location. I'm going to intersect that with my dissolve layer. So my dissolve layer is the one piece, and I'm going to select the two pieces that made it of this one. So when this comes back, I'm going to have more than likely two. I could have one, I could have three, I could have four. However many pieces made that one line, I'm going to select them all. So now I have a selection with however many features it is. In most of these cases, it's two features, the public and the private piece. So now that I have that two pieces, I need to update. I'm going to call it update cursor because I'm actually going to edit now. So there's no reason to call it update cursor unless you're going to edit. So at this point, I got two features most of the time selected, and I got my list of fields. And my list of fields in this case, again, are address and location ID. I call them outside the loop, so I'm not reassigning it all the time. That's my two values in here. I'm populating those in there. And that's the best way to do that. So you take your fields and then you unpack the value so you can deal with it. So now I'm going to say, okay, I already checked to make sure that they were both not, they were both empty. But I'm going to check again. This is just a different way to check. So if address is an empty, and our empty is the none space or single space or our empty string that we made, that I assigned earlier. Let's see, that's 135. So our empty is this empty. So I'm just checking if that value is in that list. So if it's in that list, or if locked location ID is in the list of empties, go ahead and update it. Either one of those could be empty, and it would update them both. So in this case, I'm going to call address, which is this address, and I'm going to assign it a new value. And this full address is this full address from this cursor. So this is the second search cursor. And then the same way with location ID. Notice I did, so this location ID and this location ID have different case, because if not, I would write over. If I assign this one to the all uppercase, I'd write over that value. So just be careful, case matters. So now I'm updating both of these. I'm going to say update plus equals 1. And what this does is updated count. So the plus equals 1 takes the current value of update count, which I set to 0 at the very top, and I add 1 to it. So every time this process is going to add 1 to it. I'm going to make a new row because I have a row object that I made from the fields of address and location ID, same order. And then I'm going to actually update the row. So I call cursor dot update row and then the new row, and then that one's updated. So that is a loop inside a loop inside a loop. I warned you it was going to get a little hairy. But for the gentleman who sent me this is a working solution for what you need to do. There's a little final message at the end. I say take my updated count versus my update count, which is the features that need to be updated. Make a message, throw a message on there. I did discover during my processing that you had to do 5 foot, 25 foot, 30 foot, and 35 foot to get them all to assign. So we did 5 foot, and I need to do 25 feet next. And we'll get different messaging as it goes along. So it says 32 records need to be updated. Our first one, if you remember, did 100 of the 32. It says 2 features were updated out of the 32. They need to be updated. So if we run this again, and we do 30, it says 30 records need to be updated because we updated 2 last time. It says 20 features were updated of the 30 that need to be updated. And then if we run this at 35, so I'm just going to my results and I double click it, it opens up. That way I don't have to keep repopulating these fields. 35. 10 records need to be updated. 10 records were updated of 10. So now they're all done. So this is the case where I added the 40 feet. Doesn't matter what we do at this point because we have a trap in there that says no features need to be updated because we checked, and that first selection is 0. There's nothing to update. That is a lot of information for a intro class, but for the gentleman who asked me for that, that is a working solution. I'm going to send the solution out, not the data. He didn't authorize me doing that, so I'm going to wrap it up there. I know Megan's got to get going. I have to get going. We will go over another example, a more complicated example at the end of the next webinar. The next webinar, I'm going to touch on interfacing with the map. So if I'm in here, I want to enter access with the table of contents. I want to export something out. I want to, these are 5 of my favorite tools that I've built myself. And if you want to, we can look at some of those as well. So Megan.
Great. Well, as always, thank you, Bert, for volunteering to share your time and expertise with us today. As a reminder, in the coming days, I will be emailing out the recording as well as the code and the PowerPoint presentation that was used in today's webinar. If you do not receive an email from me by Monday, I would recommend just going to the ILGISA website and the past events tab, and you can access the webinar and all of the data and documents there as well. Our 4th webinar and final webinar in this series will be taking place next week on Wednesday, September 25th at 2 p.m. Central Time, and I will be sending out the dial-in and login information via email prior to the webinar. Again, thanks for being here, and we'll talk to you next week. Bye-bye.